Hi everybody and welcome to the Unchanneled Video Blog, and today what I want to do is find out the resistance of the human flesh. Now the reason why I'm doing this video is there is another YouTube host who actually electrocuted himself to determine the pain versus AC and DC voltages. And it was a cool video, I'm not going to lie, it's really intriguing to watch. But there's a couple of things about it. He was using very low voltages. I think the highest voltage he actually applied to himself was 24 volts DC, and that was an accident. And it was cool, but you can only tell so much information from it. Because at a certain voltage, actual electricity can pierce your skin. And that's when your resistance of your human body drops really significantly. And that's what I wanted to determine, is when the voltages are high enough, what happens to the actual human resistance. It's just like a wire. There's an insulating material around the wire, and in the inside there's a conductor. And that conductor is what's going to carry all the current. So let's get right into it and actually determine what the resistance is of human flesh. So right here is the circuit we're going to be using in order to determine the resistance of the material. And it's pretty straightforward. What we're going to be doing is injecting a known current source in series to the actual load, which in this case is the human flesh, and we're going to be measuring the voltage over two potential terminals. And because we know the distance between the terminals, we can determine the resistivity for the distance traveled. So let's get right into it and see what occurs when we actually do this experiment. Now I know in the schematic it was actually a battery shown, but I'm not using a battery. What I'm going to be using today is a wall outlet, and this is North America, so it's 120 volts, and I'm running this through a variac, so it's a variable transformer. Now just to make sure that the experiment's safe, I have a 300 ohm resistance load in there, so that's going to constrict the current that's actually flowing into the circuit. Now one thing about the human flesh is we're both resistive and capacitive. So what I'm doing right now is applying different frequencies from my function generator and actually measuring the voltage at the potential electrodes like I would normally. But what we're seeing here is just how the human body reacts at different frequencies. Now at one point during the experiment I just took some numbers down and I got 19.44 as the voltage, and that was an alternating frequency. And the same with the current was 202 milliamps, and that was also an AC frequency, of course. So when we apply those to Ohm's law, we can see that the resistance over 2 inches is 96.24. Now determining the cross-sectional area on this is a little bit skeptical, so I don't want to get into analyzing that much, but as you can see, that human resistance is not that much once you penetrate the skin. Now in this part of the experiment, safety's off. I've taken off the 300 ohm load, and now I'm just applying a 120 volts, well, rising up to 120 volts using a variable transformer, and I just want to see what happens when massive amounts of current are actually applied to the circuit. And to be honest with you, not a lot happens. I was expecting some twitching and some pulsations, but nothing of the sort. The only thing that somewhat happened that was interesting was fat began to boil. Now what I'm doing is just simply applying a thermocouple around, just probing the area and seeing what the actual temperature is. Hey everybody, thanks for watching. Subscribe to my channel, more to come, and thanks so much for watching. Have yourselves a great day.